it's important to be able to annualize rates. Well, first, APR is the nominal rate, or you're taking the per period interest rate and multiplying by the number of periods per year. That's the simplest way to get it. It's probably the most helpful if you're trying to get the per period rate anyway, and it is expressed for commonality. That's the rate that we use. So what is effective annual rate though for 7.25% with monthly compounding? Now we're trying to find out how fast it would actually grow in the course of a year. It's going to be faster than 7.25%, just how fast is it? So over here to the left, I have all the things I would need to use in order to be able to pull off getting this with the basic time value of money functions. I have 7.25% for an interest rate. I have 12 compounds per year because it's monthly compounding. I'm going to start with $100 just to make things easy, and then I am going to then use the future value function to find out how much this would grow in the course of a year. So how much it would grow in the course of a year, that's the interest rate per period, APR divided by the compounds per year, multiplied by the number of compounds per year, because there's only exactly 1 year. I'm going to skip the payment part actually by leaving this empty. I'm doing the same as putting 0. Then I'm going to put the present value in. Close the parentheses. So $100 grows to $107.50 over the course of a year. So I know that it grows at 7.5%. But to get Excel to say 7.5%, I am going to take this future value divided by the negative of this present value and then subtract 1. So it's 107.50 divided by 100 minus 1, 7.5%. Excel has a function that you can do this without any kind of manipulation, and it's the effect function. And it is equals effect, and the two inputs is the nominal interest rate, the APR. The second is the number of compounds per year. And you can see we get the same answer. That's the effective annual rate. So 7.25 with monthly compounding will grow at 7.5%. The flip side of going from the annual percentage rate to the effective annual rate is to get the annual percentage rate from the EAR. So if I know that things are going to grow at 8.75% annually, then I know that they're going to go, say, starting at 100 at 8.75% interest. This is how fast it grew. So then I know the future value is going to be this $100 multiplied by 1 plus the growth rate. And I put the negative in front of it to make this a positive number. We know that. At 8.75%, $100 grows to 108.75. It took 4 quarters to get there. So now we want to find the APR. So the function for this would be rate. I want to find out what rate is being used here. So equals rate, number of periods, compounds per year. I don't have to multiply it by 1. Payment is 0. I can just kind of leave that alone. Present value, future value. So it says 2.12%, but that would be 2.12% per quarter. So to get the right answer, I'm going to take that number and multiply it by the number of compounds per year, which is 4, so 8.48%. Excel has a function for this as well. It's called nominal, which doesn't require you to do any work besides putting in the effective annual rate and the number of compounds per year. And you get the 8.48%. So 8.48% with quarterly compounding will grow at 8.75% every year.